It's Joseph from Basic Academy. I'm a chemistry specialist in IGCSE, and today I'll be guiding you towards Paper 2, May June 2023, 0620, Paper 2, Variant 2. All right, apart from this discussion, I also teach IGCSE Chemistry tutoring and also master classes. So if you're interested, you can actually go down to the link below and then just click at the link and you see what I do, and then you can join our master class if you're interested. Regardless, let's go to the paper. Okay, question number 1. 4 physical states, changes of ethanol are listed. In which changes do the particles move further apart? So in this case, you have to know the particle diagram, in which solid has closely packed particles, and then liquid has slightly loosely packed particles, but instead they're still touching each other, but the particles are further apart. And then we have gases, which is off, even further apart. So in that case, it will be, well, it can be evaporation as of liquid changing to gases, or it can be boiling, also liquid changing to gases, in which involving particles moving further apart. So answer C. Let's move on to question 2. An atom of element X contains 5 protons, 6 neutrons, and 5 electrons. Which statements about element X is correct? So we can actually copy this. There's 5 protons. So the mass number will be 11. And then it's 5 electrons, so it's an atom. So 1. X is an atomic number of 6. That's wrong. Should be proton number. It's 5 protons, so wrong. It has a nuclear number of 11. So yeah, which stands for proton plus neutron. That's nuclear number for you. And then we see it's not exactly in group 2 because it's 2, 5, which means that it's 5 electrons. It's having a 2, 3 electron arrangement. So it's not in group 2. It should be in group 3, and then it should be 2 and 4, in which it's located in the second period, given that they have 5 electrons distributed in the first and the second shell. Okay, let's move on. Ammonia is a covalent molecule, which diagram shows the outer shell electron arrangement in the molecule of ammonia. You should know that group 5 form, well, 3 lines, and hydrogen form 1 line, right? Lines as of covalent bonds. So according to their valency, that's the type of bond they can form. So from there, you should actually look at all of this, right? It seems that all of them have shown a single bond, so we can't eliminate anything from that. However, you should know that group 5 has 5 valence electrons. It will use up 2. Right, it will use up 3 for sharing, remainder 2. Hydrogen only has 1 valence electron. It will use fully. So hydrogen won't have any valence electrons left. But for nitrogen, it will have 2 valence electrons not being used in the sharing process. So C is the answer. Move on. Which structure does silicon 4 oxide most closely resemble? Silicon 4 oxide, silicon is group 4, form 4 lines, 4 single covalent bonds. Oxygen is group 6, form 2 lines. So that's the structure. And then, well, it just keeps on repeating, and we see that silicon is exhibiting a tetrahedral structure. So that's closely resembling diamond, in which diamond has also, well, diamond contains carbon in a tetrahedral arrangement as well, right? 4 single covalent bonds bonding to more carbon atoms. Moving to question number 5. Substance P conducts electricity when solid. Which particles move in solid P so that it can conduct electricity? Now, given these two, the only thing that we learn that can conduct electricity when solid are metals or graphite. So both metals and graphite can conduct electricity due to free moving electrons. Not because of cations, not because of anions, but electrons. So D is the answer. Moving on to question number 6. Which equation represents a chemical change? So chemical change, for A, it's wrong because it's a physical state change. Wrong. And then let's observe which one is a chemical change. Well, the last one, definitely not, because, well, because they are just combining these ions together, forming an ionic compound. That's not really a chemical change per se. And then C also is wrong because C, right, refers to dissolution of potassium chloride in water. When it dissolves in water, it forms potassium and chloride ions. So that's just dissolution. It's not a chemical change. So chemical change will be B. B is a precipitation reaction involving 2 aqueous ions turning into a solid chemical. Right, move on. Which sample contains the largest number of molecules? Well, we have to find out the moles. Find out moles. Okay, so first step is to find out moles, and we know the more moles it has, the more molecules it has. Right, the more moles of particles, the more moles of molecules it has, the more molecule it has, literally, right? So we have to just find the moles. So how do we convert mass to moles? Simply dividing by molar mass. So 16 divided by, for A, the molar mass of methane is 16, can be gathered from the periodic table. 12 plus 4 times 1, that's 16. So it's 1 mole. For oxygen, it is 16 divided by 32. 1 oxygen, 16, 2 oxygen, 32 mass. So that's half a mole. And then for C, phosphorus is P4. P4 would be, each phosphorus is 31. So 16 out of 31 times 4. It's quite small. And then last one, 16. Okay, this one is in volume. So to find out the mole, we have to divide by 24 because this is a gas. So that gives you around, 2 out of 3. Out of 3. So out of all, A is having the largest number of moles, which means it must contain the most gas molecules. Moving on, the concentration of a sample of dilute aqueous sodium hydroxide is found by titration. The apparatus used is shown below. Which information is needed to calculate the concentration of the dilute aqueous sodium hydroxide in mole per cubic centimeters? Okay, concentration. I want to find that, right, of the sodium hydroxide. So with that, we need to know the concentration and also the volume of the hydrochloric acid used. First, we need to know the volume of the sodium hydroxide used. That will be B. Right. Because the point being is this is about titration. It's about the hydrogen ions titrating hydroxide ions and then neutralizing hydroxide ions straight into water. So in that case, right, it's mole dependent. Mole dependent. So in which for it to be mole dependent, number of moles in a solution is equal to the concentration times the volume. So we have to know the concentration of both, or should I say one of the solutions, volume of one of the solutions, and then the other volume of the second solution. Because this is an equation already, it's like to figure out the last unknown, we must know the 3 other values so that we can know the last unknown. That's the idea behind it. All right, move on. In experiment 1, aqueous copper 2 sulfate is electrolyzed by using graphite electrodes. In experiment number 2, aqueous copper 2 sulfate is electrolyzed by using copper electrodes. Which statement identifies a half equation for a reaction at one of the electrodes? So, given that this is aqueous electrolysis, the cathode always receives copper, shouldn't be hydrogen. And then it always attracts cations. The concept is cathode attracts in an electrolytic setting. It's a negative terminal. It attracts cation. From there, we know that D is wrong. Okay. Then also, if copper is present, it must be copper. It wouldn't be hydrogen. So we know B is wrong. So either A or C. So now we have to analyze the anode. This one, default setting, anode in an electrolytic setting should give rise to oxygen gas, unless there's active electrodes or the usage of concentrated halides. There's only 2 exceptions in which we are not encountering that exception. So it must be A. In experiment 2, the anode reaction, okay, also one more thing, anode must carry out oxidation. Or should I say at the anode, oxidation is the reaction that takes place. So this is a reduction process. We know that that's wrong. So A. What? 11, sorry, not 10. 10. Which substance is not produced during the electrolysis of concentrated sodium chloride? So this one is brine. Brine produces three stuff, like in terms of electrolysis, which is chlorine gas, sodium hydroxide, and also one more thing, which is hydrogen gas. So hydrogen, chlorine, sodium hydroxide, not sodium. You cannot extract sodium from aqueous electrolysis due to its high reactivity. Move on. Methane burns in excess oxygen. The equation is shown. Bond energies are shown. What is the energy change for the reaction? So we need to break down. We need to break down 4 CH bonds. We need to break down further 2 O2 bonds. And then we need to form back 2 CO bonds. I need to form back 4 OH bonds. 4 OH bonds. Because given that 1 water has 2 OH bonds, so 2 water makes 4 OH bonds in total. So in total, bond breaking energy, delta H is bond breaking minus bond formation. That should be 4 times 410 plus 2 times 496 minus 2 times 805, and also 4 times 460. So A is the answer. Moving on. Which change increases the rate of action by decreasing the activation energy? Keyword decrease activation energy. The only thing that can do that is a catalyst. Move on. In contact process, sulfur dioxide is reacted with oxygen to form sulfur dioxide. Which conditions are used in this reaction? So it is typically carried out in 450 degrees Celsius, 200 kPa, and vanadium 5 oxide. Move on. Which reaction is reversible? Now, your hydrated and anhydrous salts. So D. Rusting is not reversible. This one is also not reversible in terms of carbonate reacting with acid. It's not reversible. And then magnesium burning in air to form magnesium oxide, also not so reversible. D is more reversible. Next, the equation for the reaction of sulfur dioxide with acidified potassium dichromate 6 is shown. What is oxidized and what is the oxidizing agent? So you should see the substance that undergo oxidation experience an increase in oxidation number. And then the oxidizing agent should experience a decrease in oxidation number. So we know for sure hydrogen is not experiencing any oxidation number change. It still remains +1 for both states. So this one must be wrong. So it's either A or D, and we know for sure it wouldn't be possible for the same substance to undergo oxidation and reduction at the same time, unless you go for higher levels. IG level is not emphasized. For this level, we only focus on single oxidation, single reduction. So D is unlikely, and in fact, it is not true, because if you notice, we analyze this question together. This one is dichromate 6 as of. The chromium is having an oxidation number of +6. You can analyze it yourself. This one is -14, oxygen carrying -2, 7 oxygen carrying -14. So together with +6 times 2, so together it's -2. That's why it's +6. You can analyze this yourself. And then it changes to chromium 3, which is turning into +3. So this is a reduction process. So which means it's an oxidizing agent. And then sulfur dioxide. Sulfur oxidizing agent is oxidation number is +4. Because oxygen is -2 each. So this one is +4, it turns into +6. Because -4, sorry, -8. Let me analyze here together. This one -8, altogether -2. So sulfur must be +6. So A is the answer. Moving on. Question 16. What is the definition of a strong acid? Acid is a proton donor. So not a proton receptor. Strong means completely dissociate in aqueous solution. A is the answer. Wait, pause. Wait. But yeah, it's pick A. C. Sorry, I just eliminated A is the answer, right? Proton donor that is completely dissociated in aqueous solution. Moving on, which statement about amphoteric oxide is correct? They can react with both acid and alkali. So C is the best answer out of all. Two examples of aliphatic oxides are zinc oxide and aluminium oxide. Moving on, copper 2 carbonate is formed when aqueous sodium carbonate is added to aqueous copper 2 nitrate. The equation, or should I say the ionic equation for the reaction is shown. How is pure copper 2 carbonate obtained from the reaction mixture? Keyword, this is a precipitation reaction, as of it's a solid product from two aqueous solutions. A solid product can be gathered by, well, filtering. So we get the residue, the solid residue, and we need to wash it and dry. This is the answer. Moving on, Q and R are elements in the same period of the periodic table. Q has several electrons in the outer shell, and R has 2 electrons in the outer shell. Which statement about Q and R is correct? So Q is most likely coming from group 7, and R is mostly coming from group 2. So group 2 is a metal, group 7 is a non-metal, so A is wrong. Then they are both in the same period, so they must have the same number of electron shells. R is found on the left, Q is found on the right periodic table, so it must be D. As of R has less proton number than the proton number of Q, because as you move across the period, you should expect to see proton number increasing. So D is the answer. Moving on, 20. Lead 2 sulfate is an insoluble salt. So which reaction produces a mixture from which it can be obtained from filtration? So we must do precipitation, which involves 2 soluble substances, 2 solutions mixing together to form a solid. In that case, we cannot use solids, we cannot use metals. The aqueous protocol to form a solid. Next, which statement about alkali metals is correct? So, first of all, going down, density increases, reactivity increases, melting point decreases. So the best answer here is sodium has a higher melting point than potassium. Right, moving on. Which row describes the properties of a transition element? It can form colored compounds, it has high density, it has high melting point. 1 and 3. Which row identifies the properties of zinc? So zinc is a metal. It conducts electricity and thermal energy well, whereas it does react with acid because it has a greater reactivity with hydrogen in an acid, in which it can displace it. Move on. Uses of metals depend on their properties. Which property is necessary for the use given? The best answer here is C. As of we want the property to fit for the usage. Power bodies, we want it not ductile. Ductile means to make it into wires. So malleable is a better property. And also not so malleable such that it becomes deformed easily, like just nice enough malleability. And then cutlery, we want to use it as a cutlery. We don't want it to conduct heat because when we hold hot food, it may cause our fingers to feel hot. That's not ideal. Not ideal at all. And also overhead electrical cables, they are held in the air, like on against gravity in a way. And then it must not have high density, it must have low density. Next, which compound both contribute to acid rain? The only 2 examples in the syllabus are oxides of nitrogen and sulfur dioxide. Moving on, PQRS are metals. P reacts with dilute hydrochloric acid forming hydrogen. Q reacts violently with water. R reacts with water to flip hydrogen. S is formed by flipping its oxide with carbon. So from here, we know Q is of the highest reactivity, which is most likely, just from the first glance, it's most likely not magnesium. Q is not magnesium. And then from further speculation, we know copper doesn't react with acids because it's less reactive than hydrogen. So most likely it doesn't react with acid. But it's C or D. Now both of them do react with acid to form hydrogen for zinc and iron. R reacts with water to give hydrogen. And then we know S is definitely wrong. Magnesium is more reactive than carbon. Its oxide wouldn't be able to react with carbon. So D is the best answer here. Moving on, which compound is formed when iron rust? Hydrated iron 3 oxide, not hydroxide. Hydrated iron 3 oxide, Fe2O3 dot XH2O. Move on. Why is cryolite used in the extraction of aluminium by electrolysis? Because it dissolves the aluminium oxide. A common mistake that students make is telling decreases the melting point. No, it doesn't. It dissolves. It's acting as a solvent. It dissolves aluminium oxide. Moving on, a wax candle is made from a mixture of hydrocarbons. The candle is lit and placed in a gas jar along with a strip of cobalt-2 chloride test paper as shown. After a short time, the oxygen in the jar is used up and the candle flame goes out. Which substance does the cobalt-2 chloride paper identify? Actually, but just by looking at this chemical, you know that it's testing for water. It turns from blue to pink as a result of the water. Next, the hydrocarbon C4H8 has two structural isomers, built 1 in and built 2 in. Which statement is correct? So, okay, this one requires more brain power. We can analyze the second half first. We know alkenes and alkanes will never have same general formula. I mean, at least in the syllabus, they won't have the same general formula. And then we know that C also is wrong, right? Alkene, they don't have the same general formula, so it's either B or D. So upon further analysis, it seems like the structural formula is correct because it's located at the second carbon. This one is located at the first carbon. So it's either, so let's look at the last sentence, has the same empirical formula as Fe. Now, what's wrong here? Huh? Oh, I see now. Wait, is it? No. Yeah, the formula is obvious. So it must be B. Because as you can see, this is a weird formula. It shouldn't look like that. Build 1 in should look like CH3, CH2, and CH2. Like this. So the technical side is CH3, CH2, CH double bond, CH2. The formula is wrong for D. Okay, next. Which compound rapidly decolorizes aqueous bromine? That is our build alkenes. Alkenes test positive for bromine test. Right? It's unsaturated. It will quickly react with bromine and form a bromoalkene. Next, what are the products of the addition reactions with alkene with bromine and hydrogen? So, well, addition reaction just means you just install it. So we get with hydrogen, we will form alkene. So CH3, or CH2, impossible. If you draw the bonds to C, then CH2Br is a double, what do you call it? It forms a dibromoalkene. Yeah, not single. For addition reaction, because bromine carries 2. So it will carry, there will be 2 atoms that get added to the molecule. 33. Ethanol is manufactured by fermentation and the catalytic addition of steam to ethylene. Which role describes an advantage of both methods? Fermentation you need to purify the ethanol, definitely, because it forms a lot of nasty products. The yeast actually produce a lot of nasty products. It's a batch process, correct? So A and B are more like disadvantages. Slow also, 3 is also disadvantage. So in terms of advantage, we know that's D. So the first 3, these are disadvantages for an industrial standpoint. So D is true because we use glucose, in which is renewable, and then the ethanol produced is pure for the catalytic addition of steam to ethylene process. Then 34. Methanoic acid and propan-1O react to form an ester. What is the structural formula of the ester? Well. We have to cut the C-double-bond-O. Like, no, in terms of COO, we have to cut from here, then we analyze. This is not even ester, this is carboxylic acid, COOH. So propyl methanoic, first name alcohol, second name carboxylic acids, three carbon, one carbon. So it will be what's the answer? Double check the answer. Yeah, propyl methanoic. The one that carry the CO is the carboxylic acid component, carboxylic acid residue. So A is the best answer out of all. 35. What is the correct structure of PET? You have to know that PET is a polyester. So amides are rejected. We reject amides. Amide has NHCO linkage. So either B or D. And look at it. It seems like B. This is not possible. I mean, not to say not possible. This is not even in the syllabus. This is a ketone. It's a different thing already. So it's like this. C-double-O, C-double-O, C-double-O as an ester linkage connecting the units together. Okay, moving on. Alkenes undergo substitution reaction in the presence of UV light. Which equation represents the substitution reaction of alkene? So we know that alkenes undergo substitution to form haloalkenes. It doesn't form alkenes. A is wrong. So it's either B, C, D. It doesn't react with hydrogen chloride, it reacts with halogen. Then byproduct must be a hydrogen halide, not hydrogen gas. Okay, it forms a haloalkene. It has a hydrogen halide as a byproduct, and then it reacts with halogens. That's substitution in a nutshell. Next, methane reacts with chlorine in substitution reaction. How many different products containing a single carbon atom can be made during the reaction? So, now methane is 4 hydrogen, which means it can have a possibility of having all of its hydrogen getting substituted, so 4 products are possible. Moving on. Rock salt is a mixture of sand and salt. The method used to separate the sand from salt is listed. Crush the rock salt, add to warm water and stir. Pour the mixture through a filter paper held in a funnel. Evaporate the water to crystallize the salt. Which statement about the method is correct? So let me draw. We will get sand as the residue, salt water as the filtrate. So not pure water. Residue should be sand, not salt. The solute is salt, correct. So the solvent is water, not mixture of sand and salt and water. So solute is salt. Next question. 2 compounds, M and N, are dissolved in water and separated by chromatography. The results are shown. What is the RF value of M and which compound is the most soluble in water? So as you can see, M completed 2 out of 10 of the solvent fund for the baseline. So the RF value is 0.2, 2 out of 10. And the most soluble compound is the one that traveled the furthest, so N. Alright, the one that traveled the furthest is the most soluble. And last question. When acid is added to salt X, a gas is produced which turns lime water milky. That will be a carbonate. A carbonate release carbon dioxide when acid is added. When sodium hydroxide is added to salt X, a gas produced which turns litmus paper blue, but it's X. So, well, this salt has produced ammonia upon adding alkali. So it must mean that it must be an ammonium. So it's ammonium carbonate. And that's it for the discussion. If you like how I teach, you can also join my masterclass. It can be found at the bottom of the link. I'll see you in the next video. Thank you for watching, and bye-bye.